Bueno, vamos a dar paso a la ponencia invitada de título Presente y Futuro de los Programas de Observación de la Tierra de la Agencia Espacial Europea. Antes de empezar la ponencia, bueno, en primer lugar agradecer a Ramón Torres su disponibilidad para estar aquí y darnos esta ponencia, y voy a dar un breve currículum de Ramón. Ramón Torres es Project Manager de Sentinel-1 desde el año 2010 y responsable de la definición de esta misión Copérnicus y del lanzamiento de Sentinel-1A, 1B, en la actualidad del 1C. Se unió a la Agencia Espacial Europea en el año 1989 y ha contribuido a misiones de observación de la Tierra desde el RS-1, RS-2 y ENVISAT. Ramón es ingeniero en telecomunicaciones por la Universidad Politécnica de Madrid y tiene un máster en Ingeniería de Sistemas Espaciales por la Universidad Técnica de Delft. Inició su vida profesional en Madrid, en el INTA y en RIMSA. Cuando quiera, Ramón.
Thank you very much, José Antonio, for the introduction. As you mentioned, I've been working in the Copernicus program since the very beginning. So in the early 2005, when we started shaping this program, and I also had the privilege to work for the Sentinel-1, what is the, as we say, the first and the best of the missions which integrate, or they are integrated into the Copernicus program. I mentioned before that it was my pleasure and my appreciation on behalf of the European Space Agency, but in particular on behalf of my director, that she asked me to support this conference, give this keynote, and pass you this message. And I would like just to go through it from Simonetta. Simonetta has been supporting the association from the very beginning, and I would like just to reflect her words. I said I would have wished to be with you today for this important event. I've been closely associated to your activities in the last years, and today, in my new role as Director of Earth Observation at ESA, I would like to maintain the close relation with your association and your community. Spain is a key player in ESA and in Earth observation, with a strong participation in ESA Earth observation programs and with the national activities. The Spanish industrial Earth observation sector has acquired strong competence over the years with programs like CEOSAT Ingenio, and this was recently confirmed by the lead role of Spain in important European missions like the Copernicus, LSTM, Sentinel expansion. I look forward to continue this cooperation with the upstream and downstream sector in Spain, as well as with the scientific community. And I'm sure that you will be supportive of the proposal that we are presenting to ministers in the Earth observation domain for the Council of Ministers late this year. After the success of the ministerial in Sevilla in 2019, we must grant continuity of the activities, support the new space initiatives and commercialization, and grant economic recovery after the COVID-19 crisis with innovation technologies and programs that support meeting European challenges like the current climate crisis and the Green Deal priorities. Spain has a strong industrial potential, and I'm confident that it can benefit greatly from the investments that will be made in November. I wish you good work for these next days and for the conference, and hope to be able to be here in person with you at the next occasion. In her words, there are two main messages. One is the continuity, and continuity of the support, continuity of the ESA involvement in the Green Deal priorities and in the climate change and the support to the Earth observation. but also to the message to be conveyed to the politicians that are going to be sitting together by the end of this year, when this the ministerial conference, which is a major event for us. Because it is also what we are discussing is the economical support of this continuation for the next phases. Well, but let's start with the matter of the conference. This is one of the pictures that we are really most proud of. This is unique compared with any other, I would say, another agency in the world. That's the, in a very short summary in there, we have the three families that the Earth observation missions in ESA cover. You can see that first part is the science, so what we call the observers. That's just for you, just to focus a little bit of the way that the information is provided here. This is time, and this is the missions, right? So what we call the science or the science support, or lately Earth observers. The big family of Copernicus, starting from the Sentinel-1A in 2014, launched in 2014, with all spacecraft and families that you can see here. That it also goes. The commitment goes up to, in this case, up to 2030, and finally the family of the meteorological satellites and meteorological missions in orange, starting from Meteosat and finishing these days with the second generation of METOP and the third generation of Meteosat that will be launched in the coming years. So just a picture of the explorers, starting from Goche in 2009, that lasted until the 2013. Studying the Earth gravity field. These particular missions are planned and are defined to look in detail to some science that could be, in the case of Goche, for instance, the gravity field, to the level of detail what was much higher than what it was done before, and therefore now is the reference for all the Earth missions. SMOS, that was launched in 2009 and is still working, is a radiometer which is studying the Earth water cycle, salinity of the oceans. Cryosat, that was launched in 2010 after a first failure, Cryosat-1, a failure of the rocket, that it was resolved, launching a second one a few years later. SWARM, that there is the first mission that is measuring the Earth magnetic field. It was launched in 2013. Aeolus, that it is studying the global winds at high altitude, what has never been done before. EarthCare, that they're studying Earth clouds, aerosols and radiation in collaboration with the Japanese, that will be launched next year. Biomass, that it is also planned not in 2022, but next year as well. That it is the first mission to study or to look in detail to the biomass, but the thick biomass, not where the forests are, but how deep the carbon or the capability of the forest to do the the conversion to oxygen from CO2 over the Earth. This is the big question that we have in the formula to see the carbon cycle. Flex, that it is studying the photosynthesis that now is in the making, as well as Forum, which is being built to match the radiation budget. The Earth Explorer 10, which is now under discussion, the discussion will have the user consultation meeting precisely next week. That we hope that it will be the go-ahead to start the phase B1. And the Earth Explorer 11, that the different missions are about to start the phase 0, or the phase of the first definition, and we are already preparing the call for the Earth Explorer 12 that it will be initiated beginning of next year. For the meteorological missions, I guess that everybody knows of, obviously, Meteosat. The first Meteosat was launched in 1977, and there was the first mission of ESA and the mission that opened the great future in Europe for space. We are currently running the second generation. That the first one was launched in 2002. And then we are also putting together the third generation, which mentioned there the launch in 2021. No, it will be next year. METOP, the Meteosat are flying in the geostationary orbit. METOP is a low orbiting and a polar mission. The three METOPs were launched from 2006. The three of them are now fully operational. And we are already working now in the second generation that will be launched from 2023. And then we have the newcomer here, the last mission, that is this Arctic weather satellite. That it is to be a constellation of satellites based on a little bit of a different approach, which is the use of what we call the new space approach. But we are going to concentrate into Copernicus, which is the main subject today. And as it is already mentioned by some of my colleagues in here at the board, it is a new phase in the Earth observation from the beginning of the implementation of this concept. It is Copernicus is led by the European Union, but it is based on this European Union and ESA collaboration from the beginning. And it is the response, the European response to the global needs to manage the environment, to mitigate the effects of the climate change, and to ensure civil security. Europe is clearly a leader in this, as I mentioned already a couple of times, but it is a leader in the domains of Earth observation. In the implementation of Copernicus, it is true that Europe is been forever much more sensitive, because we are used to live very, very close together and exploiting very much our resources. You can see this thing from the satellite images. The civilization in Europe has been exploiting resources from much earlier than anywhere else, and people are very, very sensitive to it. What created this response to the needs that are now being more and more familiar all over the world. And the Copernicus also is I would say, clear approach to a European independence in respect to the Earth observation control, and which is a major contributor to the global system. As I said, the governance is depending on the European Commission. So Copernicus is a European Union program, and the program manager is the European Commission. Everything concerning space, it is delegated to us, the European Space Agency. which is the technical coordination, our dedicated missions called Sentinel, and also the support from, or dealing with the interface and the support from contributing missions. The services, the 6 services that we will come through the presentation a couple of times more, they are supported and they are implemented by different organizations in Europe, depending on within or with a particular contract with the European Commission, including ECMWF or EMSA, etc. And then we have also the in situ measurements. Copernicus is a system of systems, and it is trying to integrate everything else. I mean, everything that supports the observation of the environment. And the in situ measurements, which are both used to provide more or provide calibration and more accuracy, and also validation measurements are coordinated by the European Environmental Agency. Well, Copernicus today, the way that it looks like is a bit of this that you can see, which is, my pointer is working. So what you have in the center, which is the space component. And the space component is based on our dedicated Sentinels. The set of ground stations and data communication and data processing. The different hubs and center of collaboration that we have in here, and also what we call the contributing missions. So national missions that they are also supporting Copernicus. Then we have the in situ component that I mentioned, which is under the control on control, I would say, the coordination of the European Environment Agency. We have the service components, which is under with the center. It is with the indirect interface with the European Commission. And then we have a number of international scientific users and a number of institutional users within Europe. So far, we've been working with 6 families of Sentinels. Sentinel-1, which is radar imaging, so it's a synthetic aperture radar, so a high resolution radar, which is our all-weather day and night applications, and with the main application, or the main application based on interferometry. We'll come to it in a couple of examples later on. Sentinel, for which, I'll touch the launches in a minute. Sentinel-2, which is the multispectral imaging for land applications, urban forest agriculture. It's a continuity of Landsat, or is the European Landsat, and also a continuity of SPOT. Sentinel-3, that it is we call the ocean and global land monitoring, which is a wide swath ocean color, vegetation, sea land, surface temperature, and altimetry. Sentinel-4 and Sentinel-5 are the one looking at the atmosphere. Sentinel-4 and Sentinel-5 are payloads that they are flying in Sentinel-4 in Meteosat 3rd generation as individual payload in the stationary orbit, and Sentinel-5 that will go in METOP 2nd generation. Also, in this case, it's a low orbit, so it flies at the first one is at the 36,000 kilometers, and the other one is at 700. And it is a polar mission, so we call just to measure the low orbit atmosphere. And but for this particular one, we launched the Sentinel-5 precursor that it is already providing the first data about that already for many years. And Sentinel-6, and that it is dedicated to monitoring the ocean surface topography and making a new reference as an altimetry mission. So what we are is Sentinel-1. The first Sentinel-1 was launched in April 2014, and the Sentinel-1B was launched in 2016. Unfortunately, we had a problem with the power unit of the Sentinel-1B, and then there was around Christmas, and we haven't been able to correct it. The satellite is fully under control, but the point is that it's now providing data. This is why we immediately triggered the launch of the Sentinel-1C, that it is planned now for 15th of April next year. Sentinel-1D is already completed, and it is in storage to replace one of the others if the end of life or an anomaly occurs. Just for you, the normal lifetime that we work with is about 7 years for all the satellites that you can see there. Well, the Sentinel-2 is the high-resolution optical mission that A and B are currently operating. C and D are in the process. They are already almost completed, both of them, and they're planned to be launched in 2023 and 2025 to replace the other ones because of end of life. Sentinel-3 is similar, so A and B are operating. C and D are almost completed, a little bit later than Sentinel-2, but they are planned to be launched in 2024 and 2026. Sentinel-4 is very much advanced, and it is now waiting for the preparation or the completion of Meteosat third generation to be launched, and the same with Sentinel-5. So Sentinel-4 there are 2, Sentinel-5 there are 3. The Sentinel-5P is the precursor, that it is the one that we launched in 2017, and this is the one that has been providing data continuously from this moment on. And Sentinel-6, which is the altimeter, that was launched in 2020 with also collaboration with the US, in this case with NASA, and the second one is ready to be launched in 2025. There is something very important that I mentioned already before, which is these contributor missions that they are key to Copernicus. We have a number of optical and very high resolution national or commercial missions like DMC or Pleiad, Rapid Eye, Worldview, Deimos 2, that's Spanish, Spot, SkySat, and those. Basically, what we are doing with those missions is that we have contracts with them to provide some data gaps that they are identified with the users, and then we have this data available to us. We put this data as the rest of Copernicus free of charge. With the synthetic aperture radar, we are also collaborating with Cosmos SkyMed and TerraSAR X Tandem. And now also with PATH in Spain, and then we are also collaborating with the RADARSAT, the Canadian RADARSAT, also interchanging information, and also with those ones, we in particular with a higher resolution is also the possibility to access in particular some emergency situations like earthquakes in a faster way. This optical and medium low resolution, we are also we're considering, and then we have also the interface with Spot and ProbaV, and with in altimetry with Cryosat and JSON. I put Cryosat, although it is ESA, but it is a collaborating or contributing mission because it's not under Copernicus. I remind you again that Copernicus is under the ownership of the European Union. And then with the atmosphere, then of course we have the METOPS and the MSGs also contributing missions to Copernicus. The data is, let's say, I try to put here in a little bit of understandable picture, a bit of how the data reach out is done. You can see that I'm talking about the 355,000 users. This is incorrect. It is 630. It's more than 630,000 users registered, and it is Copernicus Open Access Hub that is the main one. But yeah, with this one we have the different users are having a direct access. And for a final, if you want, the added value products to the final user. But we have this other one, the Copernicus Service Hub, which is the one that we are also putting the products coming from this core applications of the Copernicus program. To serve the different users or the different core users of these applications. We have these collaborative hubs that there are in some countries. There are 19 ground stations that they are receiving data, and you can also access those data from those collaborative hubs. And we also have the international hub. So the international hub, that it is where NASA, NOAA, or other agencies or users in the world are taking this data from. So we're talking about numbers in the order of 1 million direct users of the Copernicus data. These are the main pillars of the core service of Copernicus. So the atmospheric monitoring service, the marine environment monitoring service, the land monitoring services, the security service, the emergency management service, and the climate change service. These are everything which is done, in particular for this core services are built around these families with a clear, if you want, responsible or coordinator, which is reporting directly to the Commission. It means that for these core services, we have a committed continuity of the service. What is important, one of the most important things of the Copernicus program is the data policy. I was talking to the major before about this, and which has been really a pillar where everything, all the number of users, the services and everything has been created upon. But down in 2007, when we started discussing this point with the Commission about the idea of having the data free and open, our approach is well, the taxpayer is already paying for this, so let's give back to the taxpayer this type of product, but with something special that there was the commitment, data commitment, and continuity. So there was the idea, because then basically what we said is the first user, it is the one that can process and can put a value added to the product and go to the final user, not the scientific user, but the final user in agriculture, in building, in urbanism, in authorities. Maritime control, maritime traffic, everything else. So then basically is that we give you the data that you paid for already, and then you can exploit it, and then you can add value, and then you can sell it. So this idea that it took a little bit of time to convince the the European Commission at that time, but now it is not our idea anymore. Now it is the European Commission idea, because it's been really one of the most important things of Copernicus and where everything is being built upon. So I would like to touch just a little bit of the Copernicus evolution, and then we will go to the some examples. So that's the indicative schedule that we have for the next future. You can see the Sentinel-1, 2, 3, 4, 5, and 6. So you can see for 1, 2, and 3, we have the 2 satellites in orbit, and then we are planning already the launch of the C and D units. You can see the Sentinel-1C is pushed forward, and then everything is planned to be launched next year, as I said, next April. So this is already in the making. I mean, in the making, the satellites are already in the making, or they are already completed. And what we are talking there is the deployment schedule. We have anyway, and then recently we've been focused on what we call the expansion missions, which is what we also call gap fillers. So from the service or the data provided to the users, there's been already a definition of other things that they are not covered. And then we've been defining missions to cover that. These missions have been already discussed at the Council with the ministers, and they are already in the implementation. So the six missions that you see there are what we call now in a phase B to C, some of them B2, some of them C, which means that we are in the preliminary design, and then the contracts are signed, and we are going ahead with this. I cannot say now that we have the full budget to have all of them completed, but the budget, it is already planned to be delivered along with the development of the missions. These are all of them are based on the prototype, and the first unit to be done by us, ESA. And then from this point on, then we will use the budget from the European Commission to build the rest of depending on the type of constellation, the recurrent satellites. So the CO2M, as they call one of the most important ones, and one of the pushes that we had most important in the past years. And this is to measure. It is the first mission to measure what we call the anthropogenic CO2. When we're talking about anthropogenic CO2, is we are trying to measure the CO2 that is generated by the human activities. They gave an explanation once that it is like looking for a needle in a pile of straws. No, it is looking for a needle in a pile of needle. So it's as difficult as that. Because when we talk of just to take an example, the Sentinel-5 or the Sentinel-5 precursor that has been operating, then we are looking for traces of gases like CO and carbon monoxide, or we're looking at the NO2, or we are looking at aerosols, looking at NO. All of these are traces. So we look for them, and then we can see them. And then we can see where this concentration of these gases are, more or less. But CO is one of the most important components of the atmosphere. So the point is, which part of the CO is colored by generated by a human activity. So there's been just as an example, as a bit of other type of information. There's been many attempts to measure this, but looking in all of them in indirect ways. Typically, I don't know, looking at the concentration of cars, and then making some estimation of what the car produces. But a direct measurement of the CO2, the anthropogenic CO2, is going to be the first mission. The idea is very challenging. It is to launch the first satellite in 2025. Anyway, I will go quickly through the others. Crystal, which is an altimeter, but it's a complex altimeter. It's a next generation of altimetry we want, and it is to look at the effects of climate change, in particular where we have polar ice and snow. CIMER, which is a passive micro radiometer. This is from the point of view of an engineer, is a very challenging thing, because it is a small satellite or a small platform with a large antenna which keeps rotating. It's pretty amazing, and it is from the engineering point of view, as I said, it's a challenge. And this one is planned to look for sea surface temperature, ice concentration, and will also provide information about soil moisture. LSTM, this has been developed here in Spain. The main or the prime contractor is CASA, or what is ADS CASA in Madrid, and this is a land surface temperature mission. We have CHIME, which is a hyperspectral. This is our the first hyperspectral imaging mission, and ROSEL, which is another radar or high-resolution radar mission, which is working in another frequency band, is to complement the Sentinel-1. And this one is much more looking in vegetation and also ground motion and also the soil moisture. Well, I'm going to skip this one because it is also putting these 6 missions into the global Copernicus approach, or the what I call it as a gap filler. And now, just to complete, I would like just to go to some applications. There, of course, there's high catching applications, the one I put together. But there are many of them which are related, obviously, to emergency cases, or the reaction of emergencies or natural disasters in many cases as well. So this is a nice one, because this is a fusion of different missions, actually Sentinel-1, Sentinel-2, Sentinel-3, and Sentinel-5. The response to the volcanic eruption in La Palma last year. You can see the image on the left is the interferogram. So this is Sentinel-1, and you can see the effect produced by the earthquake in there. The earthquakes, let's put it like this, and the lava. Second one is Sentinel-2. And in this one, we also see some of the impacts on the land, actually, and the change of the vegetation. Then we have this Sentinel-5P, which is the rest of well, actually the gas traces. As I mentioned, this is precisely, this one is measuring the SO2 coming from the eruption. And the last one is a combination of this is the lava map, which is a combination of Sentinel-1 and Cosmos Climate. Let's go in detail. We take Sentinel-1 to start with. Sentinel-1 is one of the points that Sentinel-1 has is a radar, so you can do interferometry. And interferometry, we do interferometry in a systematic way. It means that every 6 days we have an image that you can compare with another one 6 days before. And with this one, it's a fantastic tool to see what are the effects that you can see there as in an earthquake or in a fault on the right. On the left, you can see also the effect of oil spill, But I wanted to concentrate on the interferometry, because interferometry means that we can measure the movements of the ground every 6 days. It's a radar, and for those that know radar, the radar is very nice in this way. It's very user friendly, because the radar always tells the truth, independent on the weather, independent of the clouds. The radar always tells the truth. And then we will come to this in a minute. Something which is very amazing with the Sentinel-1, and as I said, is weather independent, is that we can see and then we can monitor. That's this iceberg, 874 iceberg, which went colliding this corner of the Brunt ice shelf. It is about 1.5 times the size of Greater Paris. And it stayed there for several months until it decided to move over, pushed by the winds. Something else, this is the Pine Island Glacier, also in Antarctica. Good. It's the measurements from June 2017 to January 2019. That's something very interesting, because Sentinel-1 was not planned to do these things, but now we can also measure this. We can measure the cyclones and hurricanes because of the effect that it does on the water. So we can see with the radar. We don't see the atmosphere. For this, we have other missions, but it is amazing how we can see the water. This is a clear case of interferometry. This is, as I said, a radar always tells the truth. And in particular, what we call the permanent scatterers. So the buildings are particularly reflective, and the corners of the buildings are particularly reflective to the radar. So it means that since this reflection is high, is powerful, we can use it to measure the variations. We are measuring variations of millimeters. That's the Millennium Tower in San Francisco, and it is moving. It's coming down about 40 millimeters a year. All right, so that's the type of. This is the Millennium Tower. Of course, we can do this measurement continuously, and the data is there anyway over all cities in particular in Europe, but also in the world. Typically, it is very clear that we can see, for instance, in Venice, how Venice sinks, or we can see also in Paris. Typically, there's been also monitoring for a long time of how the subsidence is done, just because of the underground works, in the case of metro, or simply because of the heavy traffic or the big lorries. So we can see how the terrain subsides and the buildings are moving. I mentioned already the oil spills. That the one on the left is the first that there was actually in the Galician coasts in April 2014. But on the second side, you can see this is an example of the ship detection. And in some cases, you can see that these oil spills are coming from typically cleaning the tanks. This is from 2014, and what I can tell you that from that moment on, the people do not clean their ships as they used to do before, because they know that Big Brother is watching. So we go to Sentinel-2, and a couple of examples. This is actually last summer in 2021. This is just, as I said, an example of vegetation. There was a good blooming of vegetation in France. They were very, very much followed by Sentinel-2. That's a case of deforestation. This is in Rondônia in Brazil. That's an image from Landsat 5 in 1989, and this is the Sentinel-2 in 2019. same area. Wildfires. This is in Russia when we had this oblast in 2018. Algae bloom that's in the Baltic Sea. And yeah, this is in August 2015. That's a case of agricultural exploitation in Saudi Arabia. These are what they call the pivots. And this image is using they are not red. The point is that this image is using the infrared. So we're painting this in red. But it is one of the best, if you want, bands to be used for green vegetation. Sentinel-3, just something, this is the fire radiative power from the Lytton fires. Typical. This is a case of hurricane monitoring, but in this case we are looking at the temperature of the atmosphere compared with the one that we saw before Sentinel-1. That's a very, actually this is a very classical and a very good measurement of the hurricane. That's also Sentinel-3, and this is the sea level rise, which is accelerating a little bit. It's been like this from 1993. We've been monitoring that even from the beginning with the ERS1 and ERS2. And at that time, there was about 3.1 millimeters a year. Now we are reaching almost 5 millimeters a year. And Sentinel-5P, this is the one that I mentioned of the precursor of the Sentinel-5s. And then we are looking at that particular gases that we are looking only for traces because they were not supposed to be in the atmosphere, and if they are in the atmosphere, it's because of some activities or some particular natural events, typically with the SO2, a volcano. NO2 that is also caused by some of the natural processes, but it is the one mainly related to industrial activities, similar as CO. So this is the ozone hole from August-September last year. This is an interesting one. This is NO2, and this is there was very interesting to see during the COVID period how of course the levels just went down dramatically because of the limited industrial activity. But if it is in Europe, it is even more clear in China. In China, they went really to a level that you can see that is almost disappeared. COVID. This is probably the only good thing that COVID brought us. And then I wanted to insist just for my last one in the contributing missions that we keep using them also to support that in support of the Sentinels, and then for which, as I mentioned in one of my previous slides, they are also a very important pillar of the Copernicus program. And I thank you very much for your attention.
Muchas
José
gracias.
Antonio, si las preguntas pueden ser
Vale. Muchas gracias por la presentación, Ramón. Bueno, pues tenemos tiempo para preguntar. Si levantáis la mano, por favor, y os presentáis. Sí, aquí.
Hola, soy José Luis Tomé de Agresta, una empresa forestal, y quería aprovechar para preguntarte. Perdón. Soy José Luis de Agresta, una empresa forestal. Quería aprovechar para preguntarte por la misión Biomass. Si nos puedes contar un poco al final cómo va de plazo, porque hablábamos de 2022, pero no estoy muy seguro porque parece que se iba a retrasar un poco. Y luego también había oído que no va a cubrir igual las zonas templadas por razones de seguridad, que me ha llegado de una manera un poco extraña. Igual nos puedes aclarar un poco si eso tiene algún sentido o realmente sí vamos a poder usarlo, por ejemplo, en Europa.
A la primera pregunta te contesto, el plan es lanzar el año próximo. De hecho, firmamos el closeout del Critical Design Review hace 2 semanas. Está yendo para adelante, sí, sin duda. Ya sabes que uno de los problemas principales fue, es complicado desde el punto de vista de la calibración del sistema, porque a esa frecuencia la atmósfera o la troposfera es de lo más raro que hay, y bueno, la troposfera y la ionosfera. Entonces ha sido algo que ha ralentizado un poco más de la cuenta el desarrollo. El instrumento está acabado, el reflector está entregado y bueno, pues ya digo que están en las últimas fases de desarrollo, de construcción del hardware, y la integración final empezará a final de este año. Pero se lanza y se lanzará con un Vega. Con respecto al otro, sí que es cierto que hay un mapeo de zonas prohibidas, pero esas zonas prohibidas son por interferencia. Entonces, esas zonas prohibidas son principalmente donde son zonas urbanas donde la banda P puede tener interferencias con sistemas de tierra. Normalmente, ya digo que en Estados Unidos hay bastantes, pero son zonas urbanas, con lo cual Biomass va a estar, está seguro, por supuesto, en las zonas de rainforest, que es donde más interesante es, y en las zonas donde esté más despoblado, que es lógicamente donde más interés tiene. No veo que sea, en este momento sí que es cierto, no pasa como pasa por ejemplo, con Sentinel-1, que no hay limitación. En este caso sí, pero yo no lo veo crítico para la misión.
Gracias. ¿Alguna pregunta más? Tenemos tiempo hasta 1:30. ¿Nadie se anima? Sí, allí al fondo.
Buenos días. Yo soy Pello, soy de la Agencia Estatal de Meteorología. Quería preguntar si la misión Cristal, que por lo que he entendido, ¿no?, es una misión destinada a determinar altimetría del hielo polar y de la nieve, si será posible determinar espesores nivosos en zonas alpinas, en zonas de montaña, o si está más bien pensada para zonas polares.
Uno de los del interés o del reto de Crystal es precisamente eso. Hasta ahora control del hielo lo tenemos bastante bien, lo hemos hecho con Cryosat y lo hemos hecho con Sentinel-3, pero es esa parte, la parte de la nieve y el espesor de nieves en zonas alpinas, de tipo alpino, es donde es uno de los retos de Crystal. O sea que sí que confirmo que la misión va con esos objetivos también.
Sí, aquí, por favor.
Hola, soy Jesús de la Universidad de Cádiz. Voy a seguir preguntando sobre Cristal. Y al igual que Cryosat ha dado información y valiosa información en océano, ¿Cristal también dará información de medidas en océano? Sí.
Sí, te puedo decir que también la misión, el perfil de la misión no está todavía definido. Cristal entra con una serie de objetivos distintos, pero Cristal va a estar conviviendo con Sentinel-3 y con Cryosat. Entonces, estamos todavía, ahora mismo con Cristal, estamos, como he comentado antes, en el Preliminary Design Review, y la misión no está todavía o sea, las operaciones de la misión no están todavía definidas como, por ejemplo, puede estar ahora mismo el sistema. Pero sí que también puedo confirmarlo. En cualquier caso, si quieres, podemos hablar, para los que estén interesados en Crystal, estos días podemos tomarnos un café y os cuento un poco más. ¿Vale?
¿Alguna pregunta más? Bueno, pues entonces lo dejamos aquí y así tenemos un poco de tiempo antes de empezar la primera sesión oral de agricultura. Gracias.